Hello, it's Dr. Bhatt here. Having learned and got an idea about the free energy in our earlier presentation, we now move to use this concept of free energy in solving many questions thermodynamically with the equilibrium constant. We shall know how free energy of a system is related to the equilibrium constant of a chemical reaction. And since equilibrium constant is being talked about and the thermodynamic relations have been discussed, we now advise our viewers and also students and learners that the basic terms about equilibrium constant be reviewed again before getting it and solving the questions related to delta G. The basic terms are the forward reaction, the backward reaction, the reversible reaction, also the equilibrium constant with respect to concentration Kc and with respect to pressure Kp. Okay, so let us see what is there for us. The topic is equilibrium, chemical equilibrium, and the relation of free energy change with equilibrium state. Of course, it is very direct, and here I have provided for simplification, I have provided a easy chart, rather flow sheet, how to determine equilibrium free energy with equilibrium constant. You see, Gibbs free energy is related with the equilibrium constant as delta G is equal to minus RT exponential logarithm. We write as ln K. And delta G, of course, it is all described here. R is the gas constant. The value is 8.314 joules per mole per Kelvin. R, it may be 0.008314 kJ per mole. That's there. We know it. And therefore, in this equation, one has to be careful about the substitution of value of gas constant R. Either the two can be substituted depending upon the conditions or the problems, the values given. T, of course, is the temperature in Kelvin, and K is the equilibrium constant of the reaction. Now, so therefore, we know that delta G is equal to minus RT ln K, and this, of course, ln is the exponential logarithm. To be more comfortable and a simplification is there, we can convert this, we can change this expression in terms of log by multiplying with 2.303. So the expression becomes delta G naught. This is termed as naught. Naught means under the standard conditions of temperature and pressure, STP. That is delta G naught is equal to minus 2.303 RT log A. Anyway, now we find, since if you review delta G naught is equal to minus RT exponential logarithm K, we very easily find out, or we can infer that the free energy change delta G naught is inversely proportional to K. That's there. So this is also sometimes referred, and we are asked to determine a relation between K and delta G naught in many problems. So let us see what's there. Interpretation of the equation. Of course, I have already given you an idea about the spontaneous reaction and a non-spontaneous reaction. Now here, the same is being applied to determine the negative value of delta G indicates a spontaneous reaction. Means a reaction which occurs of itself. Means in terms of chemical reaction, it will be that if a negative value is there, the reaction will move towards the forward direction. The products will be more favored more, where conversely, a positive value represents a non-spontaneous reaction. K is lesser than 1, and then the backward reaction will be favored. There will be the equilibrium mixture will contain reactants. But when delta G is 0 or even close to 0, what will happen? Very obviously, the reaction will be at equilibrium state. That is, the rate of the forward reaction will be equal to the rate of the backward reaction in a reversible reaction. Now here it is, of course, when we attempt questions or problems, it is necessary that this reaction calls for this expression calls for under standard conditions of temperature pressure. But normally what is there? The non-standard conditions. The questions are given or even we determine equilibrium concentration or equilibrium constant under non-standard conditions of temperature and pressure. So it needs an adjustment. We know how to convert the values from standard conditions to non-standard conditions. And of course, most important is that the equilibrium constant depends upon the temperature. So the temperature dependence must also be determined for accurate predictions. So finally, what we get, final result is, if you recall, delta G is equal to delta H minus T delta S, we have already learned. Then we can correlate all our equations that like this. Delta G naught R represents the reaction, not represents the standard conditions. So whether it is G, H, or S, free energy, enthalpy, and entropy, all are to be considered under standard conditions. Then it becomes minus RT ln log K. And K may be either Kc or Kp depending upon the medium of reaction. We know that many times, most of the times, we calculate using concentration, molecular concentration, or the active masses. Then we use as Kc. Otherwise, for gaseous reaction, we use Kp. Now, anyway, many problems can be solved like this. And further, my request, there are certain questions provided to you based upon thermodynamic relations and delta G, H, and delta S, etc. Simple questions are there. I advise you to go through them and attempt these questions and solve yourself. And if need be, you can provide the answer to me through the mail as this. Okay, thank you. We stop here and we shall be back again after some time.